Welcome to Beyond the Brackets. In this video, we'll learn the method of variation of parameters to find the particular integral. We assume the particular integral to be of the form yp is equal to a into u plus b into v, where a and b are functions of x given as follows. Using this, we can find the particular integral and the solution will be y is equal to yc plus yp. In the first question, we are asked to apply the method of variation of parameters to find the solution. First, we write the operator form of the given equation by replacing d by dx with d. So we get d square plus 1 into y is equal to cosecant x. Next, auxiliary equation is obtained by replacing d with m and equating it to 0. So we get m square plus 1 is equal to 0. The roots of this equation are m is equal to plus or minus I, which are complex roots, where alpha is 0 and beta is 1. So complementary function is given by yc is equal to c1 cos x plus c2 sin x. Take the particular integral as yp is equal to a into u plus b into v. Here u and v are taken from the complementary function. So the coefficient of c1 will be u and the coefficient of c2 will be v. So u will be equal to cos x and v will be equal to sin x. Their derivatives u dash will be equal to minus sin x and v dash will be equal to cos x. We now calculate the Ranskian. U into v dash, that will be cos square x, minus v into u dash, that will be sin square x, and cos square x plus sin square x will be equal to 1. A is given by the formula minus integral of v into r, where r is the RHS of the given equation, divided by the Ranskian with respect to x. Substitute the values, we get minus integral of v is sin x, r is cosecant x, divided by the Ranskian is 1 with respect to x. Here cosecant x can be written as 1 by sin x. So the sign in the numerator and in the denominator cancel out. We are left with minus integration of dx, so that will be minus x. B is given by the formula integral u into r divided by the Ranskian with respect to x, where u is cos x and r is cosecant x. Cosecant x can be written as 1 by sin x. Integration of cos x by sin x is same as integration of f dash of x by f of x. So the answer is log of sin x. Particular integral is given by yp is equal to a into u plus b into v, where the value of a we have got is minus x, u is cos x, b is log of sin x and v is sin x. Solution is given by y is equal to yc plus yp. Substitute both the values and that will be the solution for this question. Moving on to the second question, it is given in the operator form. To write the auxiliary equation, we'll replace d with m and equate it to 0 to get m square plus a square is equal to 0. The roots of this equation are plus or minus ai, which are complex roots. Here alpha is 0 and beta is a. So complementary function will be yc is equal to c1 cos ax plus c2 sin ax. Particular integral is taken as yp is equal to a into u plus b into v, where u will be the coefficient of c1, that is cos ax, and v will be the coefficient of c2, that is sin ax. Next we find the derivatives. U dash will be equal to minus a sin ax, v dash will be equal to a cos ax. Next the Ranskian, u into v dash will be a into cos square ax minus v into u dash will be a into sin square ax. A is common for both the terms. Cos square ax plus sin square ax will be 1. So the Ranskian value we are getting is a. A is given by the formula minus integral of v into r by Ranskian with respect to x. Here v is sin ax, r is tan ax. Ranskian value we have got is a. So minus 1 by a is constant. We'll take it outside the integral. We are left with integral of sin ax. Tan ax can be written as sin ax by cos ax. That makes minus 1 by a integral of sin square ax by cos ax. Sin square ax can be written as 1 minus cos square ax. Separating both the terms, 1 by cos ax can be written as secant ax minus cos square ax by cos ax can be written as cos ax. Integration of secant ax will be log of secant ax plus tan ax divided by a minus integration of cos ax will be sin ax by a. That gives the value of a. Moving on to the formula for b, which is integral of u into r divided by Ranskian with respect to x. So here u is cos ax, r is tan ax, Ranskian is a. 1 by a is constant, we'll take it outside the integral. Cos ax, tan ax can be written as sin ax by cos ax. So both the cos ax in the numerator and in the denominator cancel out. We are left with integral of sin ax, which is cos ax by a. Particular integral yp is a into u plus b into v, where the values of a, u, b and v are substituted. Solution is given by y is equal to yc plus yp. Substituting both the values completes the solution for the second question. The last question is given in the operator form. Its auxiliary equation is written by replacing d with m and equating it to 0. So we get m square minus 2m equal to 0. The roots of this equation are m is equal to 0 and 2, which are real and distinct. The complementary function for these roots will be c1 into e power 0x, that will be written as c1, plus c2 into e power 2x. Taking the particular integral yp is equal to a into u plus b into v, where u will be the coefficient of c1, that is 1, and v will be the coefficient of c2, that is e power 2x. Finding the derivatives, u dash will be equal to 0, v dash will be equal to 2 into e power 2x. Ranskian for this will be 1 multiplied by 2 into e power 2x, that will be 2 into e power 2x minus 0. Again, the formula for a is given as minus integration of v into r divided by the Ranskian with respect to x. Substituting the values of v, r and the Ranskian, we observe that e power 2x cancels out in the numerator and the denominator. We are left with minus 1 by 2 integration of e power x into sin x. We know that integration of e power ax sin bx with respect to x is e power ax by a square plus b square into a sin bx minus b cos bx. Here a is equal to 1 and b is equal to 1. So we get integration of e power x sin x with respect to x as e power x by 1 plus 1 into sin x minus cos x. So that gives the value of a. Next, coming to b, the formula is given as integral u into r divided by the Ranskian with respect to x, where the values of u, r and the Ranskian are substituted to get 1 by 2 integral e power minus x into sin x. Again, using the same formula to integrate, here a is minus 1 and b is 1. So we get e power minus x divided by minus 1 whole square plus 1 square into minus sin x minus cos x. That's the value of p. Substituting these values in particular integral, yp is equal to a into u plus b into v. For the second term, e power minus x and e power 2x will be simplified to e power x. For both the terms, e power x by 4 will be common and we are left with sin x minus cos x plus sin x plus cos x. Cos x cancels out and we are left with minus e power x by 4 into 2 sin x, which is simplified as e power x by 2 into sin x. Solution is given by y is equal to yc plus yp. With this, we conclude our today's topic. Here, some practice questions are included along with their answers.